Hi, everyone. I'd like to welcome you to today's presentation, brought to you by Impressive Bytes. If you haven't checked out our YouTube channel yet, you're missing out on some informative content. But for now, let's dive into today's topic, basic network concepts. We'll embark on a journey through the world of networking. We'll start with a brief introduction to networking itself, delve into the intricacies of the OSI model, understand its importance in terms of security, and then explore the devices that make modern networking possible. Introduction to the OSI model. The OSI model, or Open Systems Interconnection Model, is our roadmap for understanding how data travels through a network. Introduced in the 1970s, this model standardized the chaotic world of networking into 7 distinct layers, each having its unique role. Layers of the OSI model. Now, let's break down these 7 layers. 1. Physical layer. Think of this as the highway of our data world. It involves physical components like cables and switches. 2. Data link layer. Here, data gets its first form, the frame. It ensures a reliable link between devices. 3. Network layer. Imagine a traffic cop routing cars. That's what this layer does, but for data using IP addresses. 4. Transport layer. Ensuring your data reaches its destination safely, handling errors, and even deciding the speed of the journey. 5. Session layer. It's the diplomat, establishing and terminating connections. 6. Presentation layer. The translator, making sure data is in a language both sender and receiver can understand. 7. Application layer. The front end of this entire process, directly interfacing with our applications. Relevance of OSI to security. Every layer of the OSI model presents both opportunities and challenges in terms of security. Starting at the physical layer, where threats like eavesdropping are prevalent. Anyone with physical access can potentially tap into communications. As we move up to the data link layer, attackers might employ techniques like MAC spoofing or ARP poisoning to disrupt or intercept communications. The network layer isn't exempt from threats either. Here, IP spoofing and routing attacks become concerns. And at the transport layer, threats like SYN floods attempt to overwhelm systems, while port scanning might be used to find vulnerabilities. The upper layers, from session to application, present a myriad of challenges. From session hijacking to more recognizable threats like SQL injections or cross-site scripting attacks. The point is, understanding each layer's function gives us better insights into where vulnerabilities might lie and how best to protect against them. It's like fortifying a castle. You need defenses at the walls, the gates, and inside the keep. Common networking devices introduction. Our digital world is intricate, bustling with data. And much like a city needs infrastructure, roads, bridges, and traffic signals, our digital realm requires its infrastructure. That's where our networking devices come in. From routers that act like the post offices of the internet, directing data, to switches that ensure data packets reach the right device, and firewalls that act as vigilant sentinels, guarding against potential threats. Each device, no matter how small or large, plays a critical role in ensuring our digital interactions are seamless and secure. Routers. Let's talk about routers in more depth. In our world of boundless data, routers are akin to the busiest intersections of a sprawling metropolis. They receive data packets, inspect their addresses through IP, and swiftly decide the best path for them, ensuring they reach their correct destinations. Whether you're streaming a movie or joining a video call, that data is traversing complex networks, hopping from one router to another, until it reaches you. Switches, on the other hand, are more localized, operating within smaller environments like your home or office. Think of them as the efficient managers of a building's internal mail system. They know which apartment or office a particular letter, or in this case, data packet, belongs to and ensure it's delivered promptly. By remembering devices' MAC addresses, switches maintain an organized and efficient flow of data within local networks. Firewalls. Now, every digital realm needs its guardians, and that's where firewalls step in. Picture a grand fortress with towering walls and a massive gate. The firewall is both the wall and the gatekeeper, meticulously inspecting every individual that seeks entry. In the digital realm, these are data packets, and firewalls either grant them passage or turn them away based on predefined security rules. They're the first line of defense against potential digital threats. Additional networking devices, but our digital ecosystem isn't just routers, switches, and firewalls. We have hubs, often seen as predecessors to switches, which broadcast data indiscriminately to all devices. There are modems, translating digital and analog signals to connect us to the internet. And then, we have wireless access points, the invisible bridges that allow our smartphones, tablets, and other wireless devices to connect seamlessly to wired networks. Each of these components, though sometimes overlooked, are foundational to our modern digital experiences. Our world is more connected than ever. Behind every video call, instant message, or online game, there's an intricate dance of data orchestrated by the OSI model and enabled by our networking devices. It's a marvel of modern technology, and understanding it is crucial in this digital age. Thank you for joining me today on this enlightening journey through the world of networking. If you found this presentation helpful, don't forget to check out our YouTube channel, Impressive Bytes, for more insightful content. Together, let's make the digital world a little less mysterious. Stay curious and keep learning.